Dear students, welcome you all to the industrial pharmacy class. And today lecture we will start a new chapter that is entitled as compression and consolidation. In this chapter we will discuss the different topics including solid air interface, angle of repose, flow rates, mass volume relationship, and density. Dear students, the main objectives of today's lecture is to learn about the compression and consolidation. And in this lecture, we will discuss the solid air interface, that what happened to the solid and what are the different forces involving at the interface of a solid material, and the angle of repose, that is for the powder flow properties, that either the powder bed is good flowing, excellent flow, or poor flow, and how many quantity of the flow property enhancing material, that is lubricant and mostly magnesium stearate is used, and that depend upon the flow properties. If the flow is poor, then we have to add the material to enhance the flow rates. And this particular topic we will discuss the care index, compressibility index, and the mass volume relationship, different types of volume, as well as the density. As you know that density is mass per unit volume. Now we have to start from the definitions, that one of the terminology that is used in this chapter, that is compaction. You have heard about the compact masses. Compaction of powder is the term used to describe a situation in which the material is subjected to some level of applied mechanical force over the powdered solid. If we have to apply certain mechanical force up to some extent, and then the material over which some applied mechanical force, and in this situation on the material, application of the mechanical force up to certain level or some level on the powder solids, this is termed as compaction. And compaction can be defined as the compression and consolidation of the two phases. As you know, there are two phases system, the solid material as well as apart from the solid material there is air entrapment. If we apply certain level of the mechanical force for this powder solid, that this is the comprising of two phases, particulate solid and air, that is gaseous system, due to an applied force. So the powder bed or the powder solids where we applied a certain mechanical force, this will be compact, and compaction can be defined as the compression and consolidation of two phases system And here in this case it is a powder solid that is comprised of two phases, particulate solid and gaseous system. And when applied force over that particular solid material, that is a powder solid, and that will be compacted. And compaction is the combination of the compression and consolidation of the two phases. And the two phases system here in this case it is a powder solid, it is particulate solid gas system due to an applied force. Now here we also use the two other terms, that is compression and consolidation. That is what is made by compression and consolidation. Compression is a reduction in bulk volume of the material as a result of displacement of gaseous phase. The air entrapped, if we compress a powder bed or powder material, a solid material, then the gaseous phase will be removed, the air will be removed, and the bulk volume will be reduced. Suppose if we have a beaker in which we keep a certain quantity of the powder up to 10 ml, if we fill and then we tap or then we apply force over this mass in that particular cylinder, then the volume will be reduced from 10 ml, and due to the displacement of gaseous phase, so in this case it should be compressed. If you apply a force over any material, that is the reduction of the bulk volume will be resulted due to the result of displacement of gaseous phase. That is termed as compression. Another term we have used the definition of the compaction, that is consolidation. Consolidation is an increase in the mechanical strength of the material resulting from particle-particle interaction. If mechanical strength is increased, that is due to the attraction of the particle, and so it is termed as consolidation. So by compaction, not only the mechanical strength of the material will be increased, but also the reduction of the bulk volume will be occurred. Another topic related to this compaction and compression, that is solid air interface. You can see in the figure the different particles connected with one another, attraction, and similarly the intermolecular bonding forces and intramolecular distribution over there. Atoms are always located at the surface, that is the surface of atoms of any solid particle are exposed to different distribution of intramolecular and intermolecular bonding forces than those within the particle. You can see within the particle, that is the interior of the particle, while that is at the surface, and the atoms are ions located in the surface. You can see that is exposed to different distribution of intramolecular as well as intermolecular bonding forces than those within the particle. Within the particle, if you see that is in the figure, that is not exposed to the different distribution of intramolecular and intermolecular bonding forces compared to the atoms that is at the surface, these are exposed. You can see in this figure, that is figure 1, as indicated in the figure 1, they may be envisaged as unsatisfied, attractive molecular forces extending out and some small distance beyond the solid surface. You can see this figure, that is the figure number 1. This condition gave rise to what is called the free surface energy of the solid. This is the free surface energy of the solid because of the small distance extending out due to the unsatisfied attractive forces, molecular forces that is happening at the surface of the solid. That is termed as free surface energy of the solid. Free surface energy of the solid play a vital role in the interaction between particles and between a particle and its environment. Either the particle-particle interaction will be occur, a similar particle or dissimilar particle, or uh, interaction between a particle and the environment. That is what role of the free surface energy. Many important phenomena such as adsorption, cohesion, and adhesion, rate of solution, and crystallization are manifestation of this fundamental property of a solid. That is one of the prominent property and fundamental property, that is free surface energy. Uh, that is a fundamental property of all the solids, and such as that many important phenomena also involving uh, in the solids, like adsorption, cohesion, and adhesion, rate of solution, crystallization. These are the fundamental properties of all the solid. Because of these unsatisfied bonding forces at the surface of the particle, those that approach each other closely enough are inherently attracted and tend to stick to one another. This attraction between like particles are called cohesion. Cohesion is the attraction between like particles. In addition, when they approach each other, types of particles or solid surfaces, they are attracted towards them, leading to what is called adhesion. One is cohesion. Cohesion is the attraction between like particles. When these particles approach the other particle or other surfaces of solid material, they are attracted to them and leading to what is termed as adhesion. Adhesion is the particles attraction, that is one particle attracts a dissimilar particle, or when it approaches the other surface, other type of the particle, other solid surfaces, they are attracted to them. That is termed as adhesion. While cohesion is the attraction between like particles. This attraction gave rise to an intrinsic property of all bulk powder solids, that is, they resist differential movement of their constituent particle when subjected to external forces. This phenomenon has an important influence on the several operations like flow from hoppers, and the flow from hoppers, feeders, relative motion and mixture, and compression to produce glues or tablets. Here, the differential moment of the constituent particle when subjected to the external forces will be resisted. The differential moment will be resisted due to the attractive forces, the attraction between the similar particles, or attraction of dislike particle or dissimilar particles. And this effect may be observed in the different operation that I have told you, that is flow from half path. If we are going to compress some particles into the tablet form, or if we want to encapsulate from half path, the flow will be resisted due to the forces of attraction between the similar particle or between the dissimilar particle. And if you want to mix the product, the relative motion in the mixer will be also resisting the differential movement because of the attraction that gives rise to the intrinsic property of all the bulk powder solid. Now in this part of the lecture we will discuss in detail about the derived properties of powders or granules. The solid materials derived properties like the powders or granules will be discussed in detail in this part of the lecture. Some derived properties which help in quantification of important variables are given as volume. These are not the basic or fundamental properties. These are derived properties like volume, density, porosity, flow properties. First of all, we will discuss volume and the different types of volume. Volume is one that is termed as void volume. The volume occupied by void or empty spaces is known as to be void volume, and it is calculated by using the formula VV, that is the void volume. If we subtract the true volume from the bulk volume, then we obtain the void volume. Another volume type that is termed as the true volume, abbreviated as VT, the total volume of the solid particle which exclude all spaces greater than molecular dimensions and which has a characteristic value for each material. The granular volume, the cumulative volume occupied by the particles including all intraparticulate but not interparticulate voids. We will discuss in this lecture as well what is meant by intraparticulate and what is meant by interparticulate voids. The bulk volume, the total volume occupied by the entire powder mass under the particular packing achieved during the measurement, that is termed as bulk volume. Another terminology that is porosity, abbreviated as capital E. The symbol used for that is E. The space between the particles and a powder are known to be voids or empty spaces. That is the space between the particles and a powder mass. The ratio of the total volume of the void spaces, that is VV, to the bulk volume of the material is referred to as porosity. VV can be calculated by VV minus VT. We have also calculated the void volume by using this equation, that VV is equal to VV minus VT. Therefore, porosity designated by capital E is equal to VB minus VT divided by VB. That become equal to, if we VB by VB, that become 1 minus VT by VB. Porosity is frequently expressed as a percentage, so E is equal to, in order to achieve the percentage, and this formula we have to multiply it by 100 in order to get the percentage. So this is the formula for the percent porosity, because porosity is frequently expressed as percentage. Density, that is another derived property of the powder and granules. The ratio of mass weight to volume is known as the density. D is equal to m by v, where D is density, m is mass, and v is volume. Three different densities of powder solid based on the following ratios may be defined. For example, for one is true density, if we have to determine the true density, then we have to uh, divide the mass by true volume. If we want to determine the granular density, then we have to divide the mass by the granular volume. Similarly, if the determination of the true density, then we have to divide the in this case that is bulk density, then we have to write over here we have to divide the mass by the bulk volume in this case. One of the flow properties of the solid material, a characteristic of the flow, can be measured by using one of the technique that is termed as angle of repose. The flow characteristics are measured by angle of repose. Angle of repose is defined as the maximum angle possible between the surface of a pile, that is a heap of powder, and horizontal plane. In order to calculate the theta, tangent theta is equal to h by r, where h is the height of the pile or heap of powder, magnitude, and r is the radius. If we have diameter, then we can obtain the radius by dividing diameter by 2. As you know that radius is the half of the diameter, and theta is equal to this equation, if we put convert it into theta, theta is equal to tangent inverse h by r. Remember that h is the height of the pile and r is the radius of the base of the pile. There are different techniques or methods used for the determination of the angle of repose. One of that is fixed funnel method, that is widely used for the determination of the flow properties of the powder. Another methods include tilting method and revolving cylinder method for the determination of the angle of repose. Angle of repose is indication of powder flow. You can see in the table that angle of repose that is measured in degree, 25 to 30, showing the excellent flow of the powder. If the value within this range, that is 31 to 35, it means that the powder bed having tested it for the angle of repose has good flow. And value is 36 to 40, it means that fair flow is observed in the sample. Fluid not added needed. 41 to 45 possible may hang up. Fluid might be needed to improve the flow properties. Similarly, 46 to 55 poor flow observed in the sample. Agitation or vibration needed. And 56 to 65 very poor. Similarly, more than 60 65 very poor. For flow rates, it is necessary to determine the flow properties and the rates of the flow. One of the techniques used for that flow property, that is termed as compressibility index. A sample indications of the ease with which a material can be induced to flow is given by application of compressibility index, that is given by the equation 1 minus V by V naught multiplied by 100, because it is expressed in percentage. So we have to multiply it by 100. In this equation, V is the volume occupied by a sample of the powder after being subjected to a standardized tapping procedure, and V naught is the volume of that particular sample before tapping. That is V naught is the untapped volume and V is the tapped volume in this case. You can see the values of compressibility index chart that are shown in the following table. Percent compressibility index values and relative flowability experience from excellent to very poor, 5 to 15 a percent value of the compressibility index. It means that the powder having sample having excellent flow, the flow rate is similarly if it is 12 to 16, then it means that 5 not neither the 5 to 15 it is let me confirm that is not 5 to 15, because here you can see